We finished those Democritus in the previous session. Dalton that said that the atoms are smooth hard balls. J.J. Thomson that discovered the electrons, and he said that the atom contains positive charge. Then Rutherford that discovered the nucleus and described it as the dense center of the atom, and he said it contains protons. Then came Niels Bohr that said that the electrons orbit around the nucleus. Then came the electron cloud model that said that the electrons are moving in a cloud-like region around the nucleus. Now, next we spoke about the charges in the atom, like protons, electrons, and Chadwick discovered another particle in the atom that he named neutrons. Who can tell me the charges of these particles, please? The charges. We said this the previous time. The last session we said the charge of the protons are, boys, the charge of the protons are, the charges of the protons are positive or negative or no charge. We said protons are yes, yeah, Muhammad,
Positive.
positive. And the electrons are
Negative.
negative. And the protons, it has
Charge.
no charge. The neutrons. The neutrons, they have no charge. We stopped at this point the previous time. Thank you. We stopped at this point the previous time and we said that the charge of the proton, the charges of the protons equal the charges of the neutrons, equals the charges of the electrons,
Negative
and the
1.
neutrons, they have no. Look at this.
No charges because the neutrons is 0.
Great. The neutrons charge is 0. We said, look at this, please. I need you to write this down for today. Hang on a second. Write this with me. The atomic mass unit, or let's start with the atomic number from the previous time, and then we will later write the atomic mass. The atomic number. It is the number of protons of an element. The number of the protons in nucleus of an element. We said this is called the atomic number. Did you finish? Write it, please. Write this definition in your copy box. Then we said that the charge of the protons equals the charge of the electrons. Protons positive 1, electrons negative 1. Right? Now look at this, please. I need you to understand this part. I'll tell you a story. Once they were discovering discovering the elements. They found an atom of an element with 6 protons. According to the atomic number, they named it carbon 6. C6 means carbon. Why? Because it contains 6 protons. Because it contains 6 protons. And they counted the neutrons. They found they have also 6 neutrons. Okay, great. 6 protons, 6 neutrons, and for sure 6 electrons. But later they were searching for elements and they found an atom. Look at this. They found a larger atom with 6 protons. Hey, this is a little different from the previous one. But because it has 6 protons, we will call it carbon 6. Okay. But suddenly they found that this atom contains 7 neutrons and also 6 electrons. It's okay, because it contains 6 protons, 6 electrons. I think about it
And
as
zero neutrons.
something that is not common, and I'll call it carbon 6 also. It contains 7 neutron, not 6. It's okay, it's okay. Oh, next, few years later, they found another atom with 6 protons. Okay, 6 protons, so we call it carbon 6. But hey,
So
stop.
we have 6 electrons.
It contains 8 neutrons. What? Yes, it contains 8 neutrons.
We have 6 electrons.
Yes. So they have all these carbon atoms. They have the same number of protons. They have the same number of electrons, but they differ in the number of neutrons. Oh my
First time is
God.
6, second is 7, and the third time is 8 neutrons.
Yes, the first 6, the second 7, and the third contains 8 neutrons. So when I'm telling you what is the number of neutrons in the carbon, and I just say it like this, what is the neutrons, the number of neutrons in the carbon? Can you answer me? In the carbon?
No.
No, I have to be specific. Which type of carbon? Anyone? No, they are different from each other. So we called them with other names. We called them carbon 12, carbon 13, and carbon
Carbon
14.
14.
Carbon 12, 6 protons, 6 neutrons. Carbon 13, 6 protons, 7 neutrons. When you add them, 6 protons plus 8 neutrons, it equals carbon 14. And we called them the different forms of carbon. But this is too long, Mr. We called them carbon not the different shapes of carbon. It is very long sentence, so we called it carbon isotopes. 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 What is the meaning of the word isotopes? This means the different forms of an element. Isotopes means atoms of the same elements, that have the same number of protons, but they differ in the number of neutrons.
Neutrons.
So take a screenshot of this if you can, then you can draw it later, or leave it to the end. I will let you draw this. So as we said, all atoms of an element have the same number of protons. The number of neutrons can vary. We just said this. You may see the same element with different number of neutrons. Like we said, carbon 12, carbon 13, and carbon 14. And please, I want to drink. Now, what is the meaning of isotopes? Atoms with the same number of protons and different numbers of neutrons, we call them isotopes. Okay, atoms with the same number of protons. Look at this.
And carbon 12, 6 protons.
What shall I write here?
6 protons.
6 protons. Here,
And
carbon 13.
7 neutrons.
13
7
minus
neutrons.
6 equals 7.
7 neutrons.
6 plus 8,
14.
carbon 14. So these are called carbon isotopes.
Mr. And we can count.
You play what?
No, I say we can count.
Yes, you can count, but it's easier to understand it, you know. Carbon 12, 6 protons, 6 neutrons. Carbon 13, 6 protons, so 13
Yes, we will make minus
6
or plus.
minus 13. Look, the carbon 13, it is 6 plus something. So 13 minus 6 equals 7. 7 plus 6 equals 13. So this number is the product of adding
Of the
protons and-
nutrients and adding the protons.
yes, adding the protons to neutrons.
Neutrons.
So these are called carbon isotopes.
Carbon isotopes.
They are elements of carbon, atoms of carbon that have the same number of protons, but they differ in the number of neutrons. I need someone to read, please. Raise your hands.
I can.
Me, I can.
Okay, Ahmed, then Ala, the next one.
Yes.
Isotopes.
Isotopes. All atoms of an element have the same number of protons. The number of neutrons can vary. Atoms with the same number of protons or different number of neutrons are called isotopes. Shows figure 9 shows 3 isotopes of carbon. An isotope is identified by its mass number, which is the sum of the proton and the neutrons in an atom. The most
So the
common
mass number
isotope
means protons plus neutrons. The mass number means protons plus neutrons. Okay?
Mr.
Hang on a second, please. Yes, you don't hear him?
Page what, mister?
This is page 79.
Okay, thanks.
79. 79. Okay. 79. Continue, Ahmed.
The most common isotope of carbon has a mass number of 12, 6 protons plus 6 neutrons, and may be written as carbon-12. About 99% of naturally occurring carbon is carbon-12. Two other isotopes are carbon-13 and carbon-14, despite their different mass numbers. All three carbon isotopes react the same way chemically.
Hang on a second. We will be discussing the chemical reactions later, but I will give you a hint about this. Why all the carbons are chemically the same? Because the chemical reactions depend on the number of electrons. Do these isotopes differ in the number of electrons?
No, always 6.
All of them, they have 6 electrons. So they all have, or they all carry out the same chemical reactions. Okay, they all carry out the same chemical reactions because they have the same number of electrons. Okay.
Okay.
Hang on a second. Take out your copies, please, and start writing this, the atomic number, and then I want you to write the atomic mass. You can write the atomic mass at the end, okay? Atomic mass, write it at the end of the page, it's okay. The atomic mass is the number of protons plus the number of neutrons. Hang on a second.